SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Hi friends, so after quite a long break we are back with Scilab. As you all might have remembered that the last lecture that we have was Scilab. We introduced you to a couple of concepts like basic algebraic operations, addition, subtraction, multiplication, complex scripts, logarithms, exponentation, vectors, and a little bit of matrices. Just a quick recap of everything. We are from IIT Bombay Spoken Tutorials, which is tutorials for free and open source softwares, me and my friend Neil, and we teach you free and open source softwares, and we encourage you to conduct these kind of workshops for free and open source softwares in your colleges. These details will give you at the end of the lecture. Let us begin. A quick recap of what is Scilab. As I said, Scilab is free and open source software which can allow you to do mathematical calculations, starting from a simplest calculator to most complex calculation in the mathematics. Today we will see some of them like matrix operations, solving linear equations and things like that. Scilab, you can call it is the free and open source counterpart of MATLAB. MATLAB is licensed. You have to pay for purchasing MATLAB and use it. But Scilab is free and open source. In the previous lecture we did show you that how to find Scilab, go to Scilab website, download it and install it. But again, let me remind you one very important point during installation: you need internet connection. Your PC should be connected to internet for installing Scilab. That is very necessary because certain softwares, the sub softwares for installing Scilab will be downloaded online. So Scilab is a free and open source counterpart for MATLAB. As I said, you can use it for simplest mathematical calculations like 2 plus 3 equals to 5. And these can range up to most complex scripts like integration, differential equations, solving polynomials, everything. Yes, of course, if you talk of these things, that solving a linear equation, you can do it in a scientific calculator also. But then we have to accept that these calculators too have the limitations. Moreover, entering the details, the question in the calculator format in its syntax is something a bit cumbersome, and if you miss out, you can never know that there is an error unless you execute it. Calculators do have their limitations. You can't solve a differential equation in a calculator. Of course, matrices and polynomials you can solve, but not everything. So that's why softwares like Scilab, they come to your help. Scilab, you cannot even imagine that Scilab can also help you simulate your algorithms. If there are certain algorithms that you have some pseudo code of algorithms, what we call the pseudo code, you can execute that in Scilab. So it is exactly similar to MATLAB, same functionalities, and allows you to do same things, but it is free and open source. Now, isn't that wonderful? You get all the functionalities that you get in licensed software, that too free, open source. So in previous lecture we did see the basic mathematical operations, addition, multiplication, division, subtraction. Then after we saw complex numbers, some calculations with complex numbers. If you remember, we did had the percentage I to indicate the imaginary number, percentage I for iota. Then we went to logarithmic expressions, exponentation. Everything we did saw quickly we reviewed because those things are very simple. Log 2 will give you 0.3010 if the base is 10. So things were simple in the previous lecture. Of course, towards the end of previous lecture we went to vectors, how to insert vectors in Scilab, multiply, add, subtract vectors, the dot product and vector product of the vectors, transpose of the vectors. These things we saw. Let us extend it further. What comes after vector in mathematics? Matrices. A two-dimensional vector is called a matrix. So today we will mainly aim at teaching you matrices. some basic operations of the matrices. We may not get into addition and subtraction in detail because it's just A minus B and Scilab will do it for you. So those things are not that difficult, but yes, in the second half of the lecture we will go to solve the simultaneous linear equations using Scilab. It is very simple, you would just love it. So let's get started with the lecture. Enough of recap, and I will ask my friend Neil to start off for basic operations on matrices. Neil.
Okay, thank you Tadrash. Hello everyone, I am Neil Patel and I welcome all of you in this second session of this Scilab. And in this session basically we are going to cover the matrix operation and how to create matrices in the Scilab. Before going on that, we will first come to know that what actually the matrix is. So in the simple definition, matrix is nothing but a rectangular arrangement of the mathematical expressions. When you see a matrix, you will only see the numbers, but actually those numbers are mathematical expressions, or you can say that any expression or equation of maths you can put or you can show it as a matrix. Here for defining matrices in the Scilab, there is one convention that you have to use only capital letters as the name of the matrix. As you might remember that in the vectors we used to have the small letters to assign names to the vectors. So it is completely opposite for the matrix, only capital letters are supposed to be used. So now let us start with the matrix. Just look at the screens. Let's first start with the how to define one matrix inside the Scilab. As you all know that this is the screen of the Scilab console. Okay. When you run the Scilab, you will see the screen and one arrow will be shown at the bottom part, and next to that arrow you will see the cursor. You can start writing from their point. It's control. Okay.
Let's zoom it so you can see it better.
Okay. So let's first define one vector called one matrix called E. So to define the matrix, it should be capital E is equal to square bracket. Now you have to enter the elements of that matrix. As of now I am going to define one matrix of 2 cross 3. That means it will have 2 rows and 3 columns, so that the total number of elements would be 6. Okay. So and remember one thing also, whenever you define a vector or a matrix, the elements needed to be fed in the row column measure, okay, row measure order. So first we have to assign the elements of the first row. That would be say 5 space 19 space 15. So these three are the elements of my first row, 5, 19 and 15. You just have to put one space between two elements and Scilab will do according to that.
Or you can place a comma between elements.
Yes, comma is also allowed. Okay. After the completion of the first row's element, you have to put one semicolon. Please remember it's a semicolon, not a comma. Okay. Then I will enter the second row. It should be 8, 22, 36. That's it. My 6 elements are there. Square bracket complete. Press enter. Scilab will show you the matrix elements. Okay. In the first row it is 5, 19, 15. In the second row it is 8, 22, 36. So this is the very simple part to define one matrix. Okay. Now what I want to do, I want to extract the number 19. Okay. Where is it is actually located? In the first row and in the second column. Okay. So if I want to extract the number 19, what I simply do, my matrix name is E, then the small bracket. First you have to assign the row number in which your element resides, that is the first row, comma. in which column your number resides, that is the second element, in first row, in the second column, complete the bracket, press enter, it will show you 19. Okay, so by doing this operation you can fetch any element of any row and any column. You just have to find the intersection of that row number and column number. Okay, similarly if I want to fetch the first row, okay, so for that I will do E small bracket, the first row, column, semi-comma, then you have to put the colon sign. The colon sign will fetch all the columns for the first row. That means it will fetch column 1 that is 5, column 2 that is 19 and column 3 as 15. Okay. Oh, that should be comma, I am sorry. It should be E, comma, colon, press enter. Sorry.
Yeah, so friends, an error we made. Please make sure you don't make this error. When you define a matrix, it has to be a semicolon with separating the rows, and when you extract an element from a matrix, it has to be a comma between row and a column. So the syntax would be like matrix name, bracket open, row number, comma, column number, right? That will extract the element of that row and column. The intersection of row and column, the element will be extracted. So again, it has to be a semicolon when you're defining a matrix and a comma elsewhere. Also one more thing which Neil said, you have a colon, which means what? In you compare the syntax, it is E bracket open row number 1, comma, we haven't provided column number, it's a colon, right? Those ratio sign colon, that means all the columns. So suppose let's see if we put E bracket open colon comma 1, that means what? In place of row we have a colon, that means all rows of first column. Let's see. Yeah, I have it. All the rows of first column means 2 rows of first column. So now you should be clear that colon sign is basically all, stands for all. So E all rows first column. In the previous one we had E first row all the columns. Oops, sorry. Okay, so that means colon stands for all.
Okay, now next what I want to do is that out of those 6 elements that we have defined inside the E matrix, I want to extract those 4 elements of the second and third row and first and second row. Okay, so to do so, what we have to do, we are going to extract all the row elements, that is we are going to extract the elements from each and every row, that is from the row 1 and row 2. So for that we are going to write, okay, that let's see, now I want to fetch number 19, 15, 22 and 36 only. So for that what I am going to do is, first of all I have to write E small bracket. Now as I want elements from each and every row, I will put colon over there, then comma. Now what I want, that I want the elements from column number 2 to column number 3. So for that I can put sign of 2 colon 3 bracket close. This expression will fetch elements 19, 15, 22 and 36 for you. This simply means that you have to extract all the rows, but only those elements who are in column number 2 and column number 3. Let's see what it shows. Okay, so it's 19, 15, 22, 36. Now suppose that your matrix is too much big, okay, it's very large and you do not know the exact size of your matrix.
Okay, before that, here let me give you a small exercise. You should try it out. In our matrix, we extracted all the rows of column number 2 and column number 3. But suppose, see, column number 2 and column number 3 are just adjacent to each other. Suppose you want to extract the elements of all the rows of column number 1 and column number 3. So what should be the syntax like? What should be this expression like? Find it out. A small exercise for you, do it, because this is important. When solving certain equations you may need it. So a small exercise, try it out.
Okay, so what my friend Tadrash is exactly trying to say is that you have to extract these elements number 5 and 8 and number 15 and 36. You have to eliminate 19 and 22 out of this E matrix. Okay, so let's move on to that, what I was talking about, that if you do not know the size of the matrix and you want to fetch each and every element from that, okay, so for that what you can do is that simply you have to assign E bracket. I want the elements from each and every row, that's why I am putting colon in the place of row number, comma, dollar sign. Dollar sign will give the elements of the last column. Okay, dollar means the last. That means you do not know what is your matrix size, that is 2 cross 3, 3 cross 3, 4 cross 4, 5 cross 5, that you do not know, and you want to fetch the last element of that particular column or row, you can simply put dollar sign. Okay, so let's place dollar, so it will fetch the number 15 and 36 for you. Okay, okay, same thing you can do with the row also. Let's see what it shows. Dollar, comma, colon in the place row. Okay, so it will show you all the columns but only the last row, that is our second row having the elements 8, 22 and 36. Now next we want to find the determinant, but as you know, to find the determinant we must have a square matrix. That means it should have the same number of rows and column. So that is why we are going to assign or determine one new matrix called A. Okay, it should be equal to square bracket. Let's say my elements are 1, 2, minus 1, minus 2, minus 6, 4, minus 1, minus 3 and 3. Bracket close, enter. So as you can see, now my matrix A has been defined. It is a 3 cross 3 matrix. Now I want to find the determinant of the A. Okay, so for that in Scilab you do not have to do calculation by yourself. You just have to write one command called DET, that is DET, small bracket, name the matrix which is A over here, enter. It's minus 2. You can also do calculation by yourself to verify whether Scilab is giving the correct answer or not, but I am pretty much sure that it is the correct answer. Okay, now let's move on to find the inverse, which is a bit cumbersome process for you guys to do it manually. Okay, so Scilab makes it easy for you. So to find the inverse you have to just type command called INV, that is the first 3 letters of inverse, INV. Again the matrix name, sorry, it's capital, enter. Okay, so it will show you the inverse of the matrix A. So it is as simple as just to type 3-letter command, and you have to specify the matrix name, but be sure that you have to mention the matrix name in the capital letters. Now next we want to find the eigenvalues. So for eigenvalues the command is SPEC, that is spec, and the matrix. Okay, so it will show you the eigenvalues also.
3 eigenvalues.
Okay, it will show you, as you can see, it will show you the 3 eigenvalues. Now we will move on to the simple operations of square and cube. To do so, what you are supposed to write, our matrix is A. Okay, then you have to put the caret sign, that is shift number 6 on your keyboard. Over the number 6 you will see the sign like caret. So to enter this caret symbol, you have to press the shift and that 6th number. I want to find the square of the matrix, that's why a square, enter. So it will show the square. Similarly, I can find the cube also, that is a caret 3, enter. Okay, so this is very simple thing. Now in the next step, I want to assign few special matrices. Okay, like matrix having all the elements as 1, matrix having identity matrix that is having the 1 as an element diagonal in the diagonal manner, and all the other elements are 0. So it will be a bit cumbersome process if you have to manually enter all those things. So besides that, what we can do is to suppose I want to assign one matrix of 3 cross 3 having all the elements 0. Okay, so for that I can simply write one command, zeros, zeros, semicolon. Inside the bracket you have to assign the size of the matrix, that is 3 cross 3. Okay,
rows comma columns as usual.
Simple. Okay, so it will assign
3 rows 3 columns.
Okay, simply you can assign one name to that matrix also, says B equals to zeros 3 colon 3, enter. So it will show that now the matrix B has these elements. Okay, similarly I want to assign one identity matrix. So for that it is EYE 3 comma 3. You can see that the element 1 is diagonally represented and all other elements are placed as 0.
Okay, here it is needless to say that identity matrix has to be a square matrix, right? 0 matrix can be of any dimension. Matrix with all elements as 1 can be of any dimension, but identity matrix has to be square matrix, right? That's why EYE 3 comma 3. In zeros matrix you can have 3 comma 4 or any dimensions, that is rows comma columns. Okay, fine.
Okay, now next suppose I want all the elements as 1. Okay, so for that I have to assign ONE1 as, okay, ones. Again the row number and column number I can put anything, that will be shown as my 3 rows and 4 columns. Okay, 1 1 1 1 1. Okay, now next I want to define a matrix with a random number. I do not have specification which element should be of which number. Okay, I want to generate the random numbers. So for that I have one function called RAND for the random. What I can do is, let's say assign one new matrix called P equals to RAND. It will generate the random numbers, and then I have to assign the number of rows and columns, that I will going to put as 3 rows and 3 columns. It will show that it has generated 9 elements, okay, randomly. You do not have command over this number generation, it can be anything. Okay, and as the last thing, suppose that I forgot to append some values inside the matrix. As of now my matrix is 3 cross 3, okay, and now I want to make it 4 cross 4. That's why I have to add 3 elements in the last row over here, that is 1 2 and 3. Okay, so for that, to append elements inside the matrix, what I will do is, my matrix name is P. Okay, so I will define one new matrix called T equals to square bracket P, okay, semicolon. Now it will append the elements to the P matrix. Okay, so you have to assign the elements in the square bracket, that we know the convention. I am going to assign the elements, let's say 5 5 2. Okay, and the outer square bracket has to be closed, space, enter. As you can see, the 5 5 and 2 has been appended inside this matrix. So now the length of this matrix T is 4 cross 4. So similarly you can extend it up to any length, okay, but it should be in the square manner itself. Now Tadrash will carry on with the linear equations, how to solve the equation using the matrix function.
Okay, before that I will like to let you show something. I have the concatenation thing. There are some more details to it, so let's have a look. See, again, when you concate matrix, that means you are creating a new matrix which is joined by some two other matrices. So suppose A is my matrix, so it has to be row, semicolon, columns. Okay, the basic convention. How? Okay, I have a matrix, say A, which is a vector actually 1, 2 and 3, vector B 5, 12 and 8, and vector C 2, 7 and 4. Now I can join these three vectors to form a matrix in different ways. You can add these vectors as a row, a single row, or you can add this as a multiple rows also. Just have a look. I will open my Scilab. Let's zoom it. Okay. Suppose I have a vector A which is equals to 1, 2, 3. I define it. Okay. I have a vector B 4, 5, 6, just for sake of convenience. I have B. I have vector C 7, 8, 9, and done. So now I have three vectors A, B and C. Let me define a new matrix D. Okay, is equal to, now I want to join three matrices or three vectors A, B and C to form a matrix D. I can do it in two ways. I will put A space B space C. Okay, that means what? This means what? That A, B and C, three matrices will be simply joined as they are. See, 1, 2 and 3 for matrix A, 4, 5 and 6 for matrix B, and 7, 8, 9 for matrix C. They are just joined side by side. But now I want these three vectors to be arranged in three different rows to form a 3 cross 3 matrix. What we do while we define a matrix, what we do to separate the rows? We put the semicolons, right? Same thing, A semicolon B semicolon C. That's all, and they will be arranged in different rows. So you see, three vectors are separated by semicolons in this case, and in previous case I did not put semicolon. That means what? They will be added as rows, a single row. It won't separate it won't break up the row. Okay, so these things are very important. Semicolons, where to put, where not to put. Now I hope you internalize these things, and that's why let me go back to the presentation. Some nice concepts I have tried to put them over here. See this now. In previous case what we did was, we had a simple vector, one dimensional vector, but now if we have a matrix P, we have a matrix P 1, 2 and 3, 4, 5 and 6, two different rows. Now I want to add one more column to it. One more column to it. What to do? Think over it. Okay, see, if I want to add a row, as I want to do in the next case, see, I again have a P matrix 1, 2, 3, 4, 5, 6 over there. I want to add a row of 7, 8, 9. Can you see the row over here? I have just highlighted it with red box. I want to add a row. How we add a row? We just put a semicolon and three elements separated by spaces. Simple thing. You see, I have mentioned the command below. It will give a new matrix, let's say G, for any name you can give, equals to P. First of all, I have P matrix. I want to add a row, so I'll put a semicolon over there, semicolon, and then three elements separated by spaces. So this will add a row. This is comparatively simple, isn't it? Very simple. I want to add two rows, put one more semicolon after this bracket over here, and add another vector. You will add two rows to your matrices. So adding row is simple, but adding columns is something a bit difficult. So what we have to do? See, I want to add a column with numbers 8 and 10 to my matrix P. So I will put a command P. So this will put my first P matrix, and then I want to enter an element 8 in first row and 9 in second row, and then I have to write 8 and 9. I'm sorry, there's a mistake over here I committed. Oh, it's a blunder. It has to be 10, not 9 over here. I'm sorry. Over here I have just put 9, it has to be 10. Sorry. So you have to separate those two elements by semicolon. So, two different concepts of concatenating. If you want to add a column, this is the format. If you want to add a row, it is comparatively simple. So it is just the placing of spaces and semicolon that distinguishes between adding a row and a column. That's why in matrices, comma, semicolon and spaces, you should be clear with these three concepts: where to put space, where to put comma, and where to put semicolon. So be careful with this because we are concatenating with the matrices. Okay, so this is how we concatenate the matrices, and now this is something which might not seem important to you, but believe me, it is important. When you start doing some hefty calculations with this Scilab, these small things come to great help. Okay, so just have a look at the slides for next 30 seconds and then we'll move forward. This slide is for adding a column to matrix P. Have a look at the slide, the syntax that I have put at the below. Right, adding columns, and this is adding rows. Right, clear? Okay, again one small exercise in this specific example I will give you. See, in the adding rows, I did tell you that you put a semicolon, add 3 more elements, and it will add 2 rows. But what to do if I want to add 2 columns? Yeah, of course, there is a simple solution that you can fire the same command 2 times with different values. But why to do that? Think of something. How to add 2 columns to this? Right? Think over it. It's not that difficult. Think over it. Give it a try. And if you don't find an answer, write back to us. We'll share our email ID towards the end of the lecture. We'll give the solution, or else you can just Google it out. Okay, moving forward, elementary row and column operations. Yeah, now this is where the essence of matrix come, right? The row operations and column operations are really very important in any matrices. Let's have a look. See, if you have known how we separate rows and columns, how we identify rows and columns of a matrix, as Neil taught you just a few minutes back, how you extract a submatrix from a matrix, if you are clear with that, elementary row and column operations are not that difficult. Have a look. See, again I have the same matrix P, 1 2 3 4 5 6. I want to do a column operations C 3 2 minus 2. This means what? Column 3 will be multiplied by minus 2 and added to column 2. Is it? Right? So I have just drawn it diagrammatically. I will take column 3. So I'll just point out. Yeah. I'll take column 3, multiply with minus 2 and subtract it from column 2. Clear? How to do this? See, let's go step by step. First, what we want to do? We want to extract column 3 from this matrix. How we do it? And here is the answer. P braces open, braces open, colon, comma 3. So all rows of third column. We have third column. Okay, we will multiply it with minus 2. That I have done. I have multiplied it with minus 2, and then what? Add it to column 2. Now how I extract column 2? P colon comma 2. That is all rows of second column, right? So now I have column 3, multiplied it with minus 2 and added it to column 2. Simple enough. Now this is important. This is what? This is actually the second column. So this is, I'm updating the second column with this entire value. Is it? That is what we do with its elementary operations, right? we take column 3, we take column 2, we do the operations and then put it back to column 2. And this is the first action is actually putting the back to column 2. Okay, so I am not giving a live demo of this. Of course, you can try it out on your own. Give it a try. If you don't get answers, get back to us. Okay, elementary operations for row, right? Column operations we saw, now row operations, same concepts, nothing changed. Just what changes it, how you extract columns and how you extract rows. Okay, in this case it is R1 2 minus 2. What I want to do is I want to multiply column 1 with minus 2 and add it to I want to multiply row 1 with minus 2 and add it to row 2. So I want to extract row 1 and row 2 at the same time. That's what I do. I extract row 1 P1 comma colon. So all columns of row 1, okay, that I have it. I multiply that with minus 2 and I add it to my second row, that is P2 comma colon, that is all columns of second row, and I write it back in space of row 2. I write it back in space of row 2. Simple enough. These operations are important for matrices. It's just basic operations that you need to know, right? Scilab does it for you. Thus it is that you have to write a command, it will do it. Again, I give you 30 seconds to have a look at this. Elementary operators for column and elementary operations for row. Sounds good? Okay. Let's move towards the last part of today's lecture, solving linear equations. Now this is where metrics are applied at large. You can freely apply metrics to solve the linear equations. So now here's an example. See, I have tried to solve this in the form that we usually do in our notebooks. We just put a linear equations in the form of Ax equals to b, then we solve x equals to A inverse b. But now it's a lengthy calculation because you need to identify A, you need to identify b, you need to take determinant of A, you need to take cofactor matrix of A, take inverse of b of A, and finally multiply that with b. So lengthy process. Of course we have some other methods for doing that, but this is the commonest process. So I'll do that. See, now I have the linear equation x plus 2y minus z equals to 1, minus 2x minus 6y plus 4z equals to minus 2, minus x minus 3y plus 3z equals to 1. Right? I have identified matrix A first of all over this, right? The coefficients of unknowns forms matrix A, and the right hand side of equals to the constants will form matrix B. I have matrix A and matrix B. I have them. Let's solve this now. I will go to Scilab. Yeah, let me zoom it again so you can see. Okay, now from the equations I have my matrix A and matrix B. Let me define matrix A equals to what I had: 1 2 minus 1, next row would be minus 2 minus 6 4, and the third row is minus 1 minus 3 3. Okay, bracket close, hit enter. This is the matrix A. I hope it is correct. Okay, now I want matrix B. Matrix B, what is it? It is 1. Okay, it's a column matrix, right? So 1 semicolon minus 2 1. Now make sure the placing of semicolons over here and in matrix A. I have matrix A and matrix B fed. Okay, now what I have to do? Very simple. I'll just open the presentation once again to have a look. Yeah, what I have to do? X equals to A inverse B. Now how we calculate inverse of a matrix in Scilab? We just saw it is INV function. Let's do it. I will go back to Scilab. I'll zoom it and I'll do X equals to inverse of matrix A multiplied by B. Okay, and I hit enter. I have my matrix X as -1, 2, 2. That means in my linear equation, I'll go back to my linear equation. I have to switch between windows. What I have X equals to -1, Y equals to 2, and Z equals to 2, just in 3 different steps. My linear equation is solved. Now this is not just for 3 cross 3, it can be a 4 cross 4, matrix A can be 4 cross 4, matrix A can be 10 cross 10, and Scilab will do it for you. Great. Okay, last thing, how we calculate a matrix X? A inverse B, right? Because that's a matrix, but Scilab has one more function. You can directly divide it. Matrix we cannot divide matrix, and that's why we calculate inverse of matrix to put it in the numerator and multiply it, right? Scilab allows you to divide matrix. Let's see. I'll go back to my Scilab windows, zoom it. Okay, now let me have matrix A. Do I have it? Yes, I have it. B, I have it. And let me change the values of matrix X so that we know the answer is coming correct. Or okay, I'll put it as matrix Z. Chalo. Right, matrix Z will be our answer matrix. I will do A. It is not slash, it is backslash. Make sure not a slash, a backslash. B, and I hit enter, and my Z matrix is -1, 2, and 2. Answer comes same. So you don't even need to remember the inverse function for finding out the solution to linear equation. Isn't this wonderful? Scilab is great. Now suppose you are calculating some numerical and you have a 5 cross 5 matrix and you need to solve it. I mean 5 cross 5 linear equation and you need to solve it. We cannot imagine how much amount of time will it take. Of course we can solve it given the freedom of time. But then when Scilab does it for you quickly, accurately. Now see, when you have a 5 cross 5 linear equation and you calculate it, there are 100% possibilities that you make mistakes, and when you make mistakes, do it all over again, spending double amount of time. Scilab does it in just 30 seconds, almost 30 seconds, with accurate answer without a doubt, right? So matrices. Okay, I gave you 2 exercises in this session, right? 2 exercises. What was the first exercise? How to extract column 1 and column 3 from the matrix. I hope you work on it. Next one was how to append multiple columns to a matrix. I showed you how to append one column. Work on it, how to append multiple columns. And here comes the third exercise. And I'm not going to evaluate on you this or evaluate you on these exercises, but I encourage you to solve these exercises so that you can internalize the concepts of Scilab, you can remember the syntax that Scilab uses, and you can understand the language that Scilab uses. So let me give you third exercise, right? I solved a linear equation for 3 cross 3. I hope it is clear. I'll give you one more equation in 4 cross 4. Of course, you can take up any equation you want to solve it in Scilab, but I'll give you a equation for that, right? So let me just open my assignment. Give me a second. I have it. Okay, I missed it. I missed it somewhere. I'm sorry, and you are lucky. I missed the example where I have saved somehow. I don't know. But take up any 4 cross 4 linear equation and try to solve it, so that you know how to solve the linear equations in Scilab. Okay, so we are almost closing down for today. Enough of concepts, enough of new things that we showed you today. Before that, let me share my email ID with you. I'll open a notepad and type it over there. Yeah. It is my email ID and my friend Neil's email ID. that I am sharing with you all. Any doubts you have, just write us a mail and we'll try our best to answer your queries within few hours. Right? So this is our email IDs and we are done for the day. But before closing down, I again want to encourage you all to take down these. See how much we can teach you over here. We have a stipulated time of 1 hour. We can't spoon feed you each and everything, but I encourage you to take down the spoken tutorials workshop. Now they are for free. You don't have to pay anything, right? We'll send you the kits from here, from IIT Bombay. We'll send you the kits of the workshop. We'll send you the materials. We'll send you the CDs of softwares. Take them home, learn it by yourself, and there's an added advantage to those workshops than viewing this lecture. You have to appear for online test and you will get an IIT Bombay certificate. There are many colleges of Gujarat who have done it. There are more than 2000 colleges across India who have taken these workshops, and I encourage you to be part of the movement. I encourage you to be the part of the story, the success story that Spoken Tutorial has a dream to build off. Take down this workshop. Just a 2 hours workshop in your college. Take materials with you, study at your place, and appear for online test at your convenience. So I please again I encourage you to take down these workshops. They are for free. We are not taking anything from you. Please have these workshops so that you can understand these concepts in a better way, in an elaborate way than what we can cater you from here. Right? So that was all of for today. We'll meet in the next session. Till then, be happy. It's a festive season. Enjoy and be the force with you. See you.
SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.